Welcome to the Math Record. Today we'll be learning about partial fraction decomposition. This video would cover part 6 of chapter 3 in our Precalculus class. So what is partial fraction decomposition? Partial fraction decomposition is splitting a rational function into two rational functions or more. So basically what it's doing is say, let's say you have an equation like f of x divided by g of x, which would be like a rational function, will equal to some kind of value, let's say a, all over another function, let's call it a of x, plus another function called b over b of x. And that's what we're going to be doing. It could also add more, like c over c of x, d over d of x. Like there could be more. But in in our cases that we're going to show, there's usually only going to be 2 or 3. Anyways, let's start with the beginning one, which talks about factors. This is the most normal one, which is the factor case with non-repeated roots, non-repeated factors, so which are non-repeated. Okay, so this would be case 1. There out of 4 cases. I'll just write an example out for you. Let's say you have 6x plus 10, right? Divided by x plus 1 times x plus 3. Then what you had to do is that you had to write the denominators out first. So what you when you're looking at these decompositions, you're gonna have to find only the bottom ones. Since these are not repeated, right? These are factors and they're not repeated. Because if it's repeated, it's gonna be like squared, right? Or like cubed, right? So since these are not repeated, then what we're gonna have to do is that you write a denominator, x plus 1 as a denominator, plus x plus 3 as a denominator. And you have to look for the numerators, which we'll label as a and b, and these would be numbers. So what you do in this case is that it's like you kind of had to like combine to make the same denominator. So you have to multiply x plus 3 to the top and bottom here, and x plus 1 to the top and bottom here. So you get 6 times x plus 3. I mean a plus x times 3 plus b times x plus 1. Because then if this is x plus 1 and this x plus 1, then this and this kind of like you could add, since they're the same denominator, you could add them together. So this section has to be the same as this. You see how that works? So what we're gonna have to do is that since we had to look for the x terms and we had to look for the constant terms, this means this gets a, and this one gets b. So a plus b has to equal that linear term, so it has to equal 6. And this one's 3a. And this one is 1, so that's just a b, plus b has to equal 10. So we have to find out what a and b is using this system of equations. So what you do is that you multiply the first one by negative and you add by the second one, so you get 2a is equal to 4. So a is equal to 2, so b is equal to 4. So that's how you find out our decomposition. This would be 2, and this would be 4. And that's how you do the factors non-repeated, if it's only like one of them each. So now let's do the factors when they are repeated. So factors repeated. So in this case, let's say we have something like 4x squared plus 12x plus 12 all over x plus 3 times x plus 1 squared, right? So what you do in this case is that you have to split it up into 3 sections. So what you're going to have to do is that you write a all over x plus 3, because that's the first term. And the next term is b all over x plus 1. because that's the second one. And the third term would be c over x plus 1 squared, because this is squared. If it's repeated, if this is repeated, you have to write the next term. If this was cubed, right, then you have to add d all over x plus 1 cubed. Okay? But since it's only squared, we're only going to work with the squared case. So what you're going to do in this case is basically you're going to have to find a, b, and c. So, sorry, I forgot the squared here. Okay? So this side you have to multiply by, you have to get to this denominator. So you have to multiply a by x squared plus 1. So a times x squared of x plus 1 squared. And b, you already have one of this, so you need the x plus 3. So you have to multiply by x by 3 and by the other x plus 1. And c, you already have the x plus 1 squared, so you have to multiply this by x plus 3. So based on this case, what it tells you, it has to be the same as the numerator right here. So it says the quadratic term is just a plus b, because these are the only ones. So a plus b has to equal 4, because right here. This one expands out to x squared plus 2x plus 1. So that's the linear term would be 2a from here. This would be 4x, so this is 4b plus 4b. And this one has to be c times x, so that will just be c. And this gets the linear term, which is, if you expand this out, I don't have room, so if you expand this out, it will do it. I just don't have room. So you put this as 12. And now you have the constants, which is, this is just 1. This is just squared, so that's 1, so that's just a. And you have, that's 3, so that's plus 3b. And you have 3c is equal to 12. So let's erase some of these so I could get some room. Because after you get all the system equations, these kind of become unnecessary right here. So what you want to do is now you want to solve the system equations. So let's substitute. Let's actually cancel out the a first. So multiply the first equation by -2 and add to the second one. So that gets 2b plus c is equal to 4. And then you multiply this by -1 and add to this one. So that gets 2b plus 3c is equal to 8. So that means 2c has to be equal to 4. So c has to be equal to 2. So if c is equal to 2, that means b has to be equal to 1. So if this is 1 and this one is 2, right? So you could just plug these in. So that's what we know so far. B and sorry, actually we don't need to delete this. We have b is 1 and c is equal to 2. And now we just plug b back into here, so that makes 3. So you just need to make sure these are all correct. So a plus b is 4, yes. That's 6. That's 4. Wait, that's wrong. 6, 4. No, never mind. 6, 4, 10, and 12. And that's 3. That's 6. And that's 12. So it's 3, 1, 2. So that's the So that's how you write for a factors repeated case. You just have to write the constants. Now, the next case, the third case, would be if there were no factors. If there were there could be in combinations with these, so it could have factors and non-factors. But if there is non-factors, what you write is usually what it is just gonna be a usual non-factor case. So if there's factors in there with non-factors, you're just gonna use a non-factor case. So use non-factor and it's non-repeated. See how there's gonna be a factors non-repeated, factors repeated, and then non-factors non-repeated. So the fourth one is a non-factor repeated. But so far we're gonna work on the non-factor non-repeated. So what it's gonna say is that we have something like like 3x squared plus 3x plus 2 all over x plus 1 and x squared plus 1. Because you can't factor x squared plus 1. That's why it's called a non-factor case. So what you do in this case is that you split this up into a over x plus 1 plus b x plus c all over x squared plus 1. So if this is a non-factorable, you have to use a linear term in front. If it's not a if it's a factored form, you're gonna have to use a constant. So it's gonna be a number. So for factors, numbers. For non-factors, use equations. So what you're gonna do in this case is that you multiply this by that. So you have a times x squared plus 1, and you have b x plus c times x plus 1. So you get ax squared plus a, and you get bx squared plus bcx, b plus cx, and then you have to add in c. So what we have to do is that we have to get the quadratic term. So a plus b, so right here, has to equal 3. Which is also true right here because a plus b is c, and this one's the only linear term, which b plus c is also 3 right here. And also a plus c is 2. So let's just put this by negative. So that's negative a, and that's negative c is equal to negative 2. Add that to this, so b minus c is equal to 1. So that means b has to be equal to 2, because if you add this to this, that'll be 2b is equal to 4, so b is equal to 2. So right in this case, we're going to get b is equal to 2. If b is equal to 2, that means c is equal to 1, right? So if b is equal to 1 right here, that means a is also equal to 2. Which, let's say, so we got to check if that's right. So a plus b has to equal, wait, sorry. Since a is 2, b is 2, a is equal to 1. So a plus b is 3, so this plus this is 3, yes. B plus c is also 3, so 2 plus 1 is 3. And a plus c has to be equal to 2, so this is this, which is true. So this is true. This is not in the equation. This was part of the equation. Part of this equation, not the system. So that is true. So that's how you do for non-factors repeated. And now the fourth and final case, which talks about non-factors repeated. So non-factored repeated. This basically has to do the same thing as the factors repeated. So let's say you have something like 2x cubed plus x squared plus 3x plus 2. Sorry, that looks bad. I'll rewrite it. 2x cubed plus x squared plus 3x plus 2. Okay. All over x squared plus 1 squared. Right? Since this is a non-factor, you're going to have to use a non-factor repeated because there's a 2 right here. In any case there's a 2 and above in x's as its degree or exponent or whatever is referred to as, you're going to have to use the non-factor repeated if it's a non-factor and there's multiple of them. So as I shown before, you have to write a x plus b for non-factors, which is ax plus 1. And then you have to write the next term, which is cx plus d all over x squared plus 1 squared. See, you see how that works for like factors repeated and non-factors repeated? Now you have to write the linear term twice. because there's a squared repeated. X plus squared plus 1 repeated. Right? So what you're going to have to look for now is that you have to multiply this entire thing by x squared plus 1. And this side is already x squared plus 1, so you just leave it as cx plus d. So what you get is that you get ax cubed plus bx squared plus ax plus b. Since we only have one x cubed term, because this is the only one left, equals from here, it's just cx plus d because nothing's happening to it. Since a is the only x cubed term, that means it has to be equal to 2. So a is equal to 2. Right here is 2. So we got this term down. So now we have to get the quadratic term. So that's bx squared. Since bx squared is the only one with the x squared term, that means b is equal to 1. And now we have to say a plus c is equal to the linear term, which is 3. And we already got b here. I mean, a right here is, we already got a, which is 2. And we already got b, which is just 2 and 1. So a is 2. So c has to be equal to 1. Which makes sense, because now it's a 3. And now, so this is a 2. And we already got b is equal to 1. So b plus d, alright on top. B plus d has to equal to the constant term, which is 2. So since we already know b is 1, that means d is also 1. So it will be 2x plus 1 over x squared plus 1 plus x plus 1 over x squared plus 1 squared. So that has to make sense, which is true, because then a is 2, makes sense. B is 1, that makes sense. A plus c has to equal 3, which is true. This is a plus c, so 2 plus 1, 3. And b plus d has to equal 2, so b plus d, which is 1 plus 1, which is 2. So this is correct. So that's basically all 4 cases for the partial fraction decomposition. So in summary, if you have a factored, non-repeated, just make 2 factored partials, fractions, and then and have constants in top of them in the numerator and add them. If it's a factors repeated, you write the factor that's repeated twice, but one of them is 1 degree less than as the other one. So if it's like x plus 1 squared, it will be x plus 1, a over x plus 1 plus b over x plus 1 squared. If it's a non-factored, non-repeated, what you do is that you write a linear equation. So you have to have ax plus b all over the non-factor, which is like, let's say, x squared plus 1. And then if it's a non-factor repeated, you have ax plus b right here over like a squared plus 1 plus cd plus cx plus d over x squared plus 1 squared if it's squared. So the linear one and then the squared version. So that's what you do. So those are all 4 cases. Anyways, thanks for watching, and I'll see you at the next math record.